Kuldeep, can I get your background educational qualifications so that I can know like what qualifications you have right now, and based on that I can teach. Like, are you the master's student or not? And are you doing your master's in geography or in some other subject? So I want to just know about it. Okay, okay, thanks. I understand your problem. It's all right. Hello, Khushbu, are you here?
Evening, ma'am.
Good evening. And where is your friend?
I don't know, ma'am.
Okay, so I think it's Sunday, so they might go somewhere else, like in the market or somewhere.
Maybe.
It may be it may be possible, right?
Yeah, ma'am. Yeah, ma'am.
Okay, I think we should start our live session. So let me share my screen with you people. Okay, Kuldeep. Khushbu, can you see my screen?
Yes, ma'am. I see.
Okay, okay. Okay, so let me introduce myself first. So I'm Jyoti Sharma and I'm doing the TA-ship under Dr. Arun Avadhia, Ankur Avadhia actually. And this, I will be taking your live session from 6 to 8 p.m. every Sunday. So this is the week 4 content. And this week I will try to give you the solution of the assignments, like the old assignments, not for the new assignments. So let's start. So today the content will be, I will talk about the atmosphere, how the atmosphere evolved, what are the different layer of the atmosphere, the composition, the energy, the source from where the atmosphere get the heat and energy, how the energy moves within the atmosphere, and what's the heat budget or the energy budget. Okay, so this will be the first session. The second session within this live session will be the atmospheric circulation and weather, in which we will talk about atmosphere pressure and how this pressure distribution can lead to the atmospheric circulation and the air movement. Then we will talk about the air masses and fronts. What are these and what different type of air fronts and air masses we have on our earth. Then we will talk about the general circulations, then seasonal and local winds, and some short description of the cyclones as well. Then the third session will be climate and climate change, in which we will talk about the difference between uh, climate and weather. Then how this climate change is happening, what are the different components of climate as well as the climate change have. Then the response we get from the climate change, what the strategy we can adopt in the against this climate change, either the mitigation or the adaptation, and what option we have regarding the adaptations and what is the maladaptation. So this kind of content we will try to cover in this live session. And yes, plus we will try to solve the assignment that has been given to you on Swayam website. So let's start first with the atmosphere. So, what's the atmosphere? Atmosphere consists of two words. That one is atmos and second is sphera. So, atmos means vapor and sphera means sphere. So, from it we can like You can see here it is our earth, and this layer has so many gases around the earth. Okay, so definition of atmosphere can be the layer of gases surrounding a planet or or other body. It may or may not be that the planet has the atmosphere, other body can also have the atmosphere. If this planet or some other body have some gravity and some have some masses, then that body can also have the atmosphere. Okay, and these layer of gases can be held, like it is compulsory that it is held by in place by the gravity of that body. Okay, so I think one assignment question is related to what are the conditions in which atmosphere will be present around your planet or another body. So there are two conditions that must be applied. The first is there must be an appreciable gravity. If there not be any gravity, if there is a very less gravity of a planet or of another body, so what will happen, these gases will not be attracted toward the center of that body or the planet. These gases can escape into the space, so there will be no atmosphere. So the first condition that should be followed is that there should be the appreciable gravity. The second is there should be low temperature. What do you mean by low temperature? For example, if you have a high temperature, then this high temperature will expand your air, will rise your air, and after expansion, the this air will go away from the planet. Okay, and if it go away from the planet, then there will be less gravity as well. So the layers of the gases can be escaped into the space very easily. So two conditions, the appreciable gravity and the low temperature is must, uh, so that atmosphere can be here around the planet or another body. Okay, so this is kind of fact that we have the largest planetary atmosphere that is surrounded of the Jupiter planet, and very thin atmosphere we have of the Mercury. Uh, okay, so this is all about the atmosphere and how atmosphere can be present around the planet or another body. Say sound. Okay. The second is how Earth atmosphere has been evolved. So I think already in week 2 or week 3, I have explained how the atmosphere has been evolved. But for your kind information, let me repeat it once again, because you know that Earth is formed from a nebula, and when it was a nebula, the gases were trapped in this. Okay, and what were the gases? The gases were hydrogen and helium. But as we know that this sun has a solar wind. That solar wind can faded away the gases that we had at that time. So because of the sunlight, because of the solar wind we had, the helium and the hydrogen escaped into the space. Okay, so at that time we had no atmosphere. This was the primary condition. What happened next? That in the within the earth, degases happened. What was the degassing? Degassing means the release of gases or the chemicals from earth itself. Okay, so for example, we had the volcanic eruption, and during the eruption, the sulfur dioxide, carbon dioxide, the water vapor has been released within the earth. Okay, so the secondary atmosphere, the gases we had in the secondary atmosphere were water vapor, CO2, SO2, etc. And at that time, because we had the water vapor and some cooling has been happening, so ocean formed at that time. So this was the secondary atmosphere. What happened next? That after some time, after some billions of years, the photosynthetic life survived on the earth. Okay, so photosynthetic means they are taking the CO2 and releasing the oxygen in the atmosphere. So this event is known as the oxygenation event, in which oxygen was released and CO2 was absorbed. So right now we have that kind of atmosphere in which we have approx 21 percentage of oxygen and 0.03 or 0.04% CO2 in our atmosphere. And now the most important atmosphere we have, that is anthropogenically modulated atmosphere, because whatever the atmosphere has been formed by itself, it has been modulated by the humans. For example, we are releasing the carbon dioxide, we are releasing the methane, we are releasing the CFCs gases in the atmosphere. Some gases that were not known naturally has been released by the human itself. For example, the nature didn't have the CFCs, that chlorofluorocarbons, but human made that gas and is releasing this gas in the atmosphere. So this is the anthropogenically modulated atmosphere. Then we will talk about different layers of the atmosphere. What different layers we have? The first is troposphere. Here you can see the troposphere is the lowest layer in the atmosphere, that is very near to the Earth's surface. The average height is 0 to 12, but in the equator the height is 18 kilometer, but in the poles it is only 8 kilometer. So Khushbu, are you here?
Yes, ma'am.
Khushbu? Yeah, may I ask you question, why the equator has a highest layer that is 18 kilometer, but the pole has only 8 kilometer height? What's the reason behind it?
Uh,
Uh, uh, my question is clear to you, Khushbu?
ma'am, can you repeat this question?
Yes, because we know that the average height of troposphere is only 0 to 12 kilometer. Okay, but if because it is the average height came from the equator and poles. Pole have a height that is only 8 kilometer. Like 8 kilometer troposphere we have at the poles, but at the equator we have 18 kilometer troposphere. So why there is a discrepancy? Why there is a difference between equator and poles troposphere height?
Ma'am, it is due to differentiation in conventional currents.
Exactly. Your answer is very much right. Let me explain it. Because in the equator, the solar heat is straight. Okay. Because of higher solar heat, air will rise very at a higher height, but at the polar we have a cooler air and we don't have that convectional currents. Because of convectional currents at the equator, we get the troposphere height up to 18 kilometer, but at the poles it is 8 kilometer. Khushbu, you were right. Thank you. Okay. So next, so right now you know about the average height of the troposphere. Then the second characteristic of the troposphere is that the 99% of water vapor and aerosols are here only in troposphere, not in other sphere, because we have the oceanic bodies, we have the rivers. Every water body evaporates some water for convert into the water vapors, and we have the crust, we have the surface from where aerosols can be formed. Okay, so this will be formed near to the earth surface only, and near to the earth surface there is the troposphere. So there is the one question in assignment that's in which it has been asked that in which layer then most of the water vapor and aerosols occur. So the answer will be troposphere. The third characteristics is that the temperature decreases with height. Khushbu, can you tell me once again, like why the temperature is decreasing with height here in troposphere? Khushbu? Okay, so let me tell you about this. This is known as whenever with the height the temperature decreases. This phenomena is known as lapse rate. So this happens because whenever the air rise, warm air rise, it it expands, and after expansion it cools down. Okay, so near to the surface the air was warmed, but at the height it will expand, and after expansion it will release the energy and it will cool down. So this is the lapse rate, the decrement in the temperature with the height. So this is the characteristic of the troposphere. The four characteristic feature of this troposphere is that most of the weather phenomena occur here. This is very obviously that because most of the gases, most the concentration of gases is highest in the troposphere. So whatever the and even we have the crust, we have all the different type of uh, earth features in the troposphere. So whatever the weather phenomena will occur, it will occur in the troposphere, except some cases such as uh, cu- uh, cul- cumulonimbus thunder clouds rising into the stratosphere. We will talk about it in the next slide. Then most of the aviations occur here at this height. This is also obvious that this will happen in the troposphere. Let's talk about the stratosphere. It starts it starts from this 12 kilometer to around 50 kilometer. So here we can say the next to the troposphere is the stratosphere, and this is home to the ozone layer. Because this is the home to the ozone layer, and ozone layer will absorb the ultraviolet radiation. Because of the ultraviolet radiation absorption, the temperature will increase with the height. So here it is inverse. In the troposphere, temperature decreases with the height, but in the stratosphere, temperature increases with the height. Okay, and it is nearly cloud and weather free because at that much height, our air with moisture will not go up at that height. So that's why here the cloud here we have nearly cloud and weather free, except some clouds that has been happened in the polar region. We will talk about this as well later. Then the flight of jet planes, because there is no any obstructions such as like in the troposphere we have clouds, here we have very less cloud or nearly free weather. So the jet planes can take the flight in the troposphere very easily. So here you can see the cumulonimbus thundercloud here. The height, its height can be go up to the stratosphere. It start from very low and it go to very high, even up to the height of the stratosphere. And these cumulonimbus will lead to the thunderstorm and the heavy precipitation as well. So these are the cumulonimbus thunderclouds. Now the third layer is mesosphere. This mesosphere ends to around 80 kilometer, and it started from 50 kilometers. So 50 to 80 kilometer, here is the mesosphere. In the mesosphere, the temperature decrease with the height because there is no such phenomena as in the stratosphere where ozone absorb the ultraviolet radiation. So this is not happening in the mesosphere. That's why here, same as the troposphere, the temperature decreases with the height. The one of the interesting thing here is that here is the noctilucent clouds. Okay, so why this? What do you mean by this noctilucent clouds? Nocti means at the night. Lucent means the shining. So cloud shine at the night time. Here is the picture. You can see. So what happened? These clouds are made up of ice only. Okay, so at that height, the water vapor will convert into the ice, very thin ice, and because of the scattering, reflection, diffusion, these will reflect sunlight in the at the night time. So this will it will look like this, loctinosen. And there is the one question in the assignment where it has been asked that where this noctilucent cloud forms. So it is in the mesosphere. The next characteristic feature of mesosphere is most of the meteors burn in this layer. So I want to ask the question, why meteor burn in this layer? What happens to the meteor that it get burned? So can anyone please tell me? Okay, Kuldeep, you can't speak. Maybe you know the answer, but I will go to the Khushbu because she can speak. Khushbu, can you tell me the answer? Why meteors burned in the mesosphere? Okay, let me explain the answer. Because whenever the meteor rocks come into the mesosphere, there is some gravity issue because of the high gravity. Sorry, not gravity. Sorry. It's the frictional. Okay. So here is the friction force that will be experienced by the meteor rocks, and that friction force, because in the friction force caused by the gases in the mesosphere, it will make the very hot meteor, and this hot meteor will be burned in this layer. So this is because of the frictional force that has been exerted by the gases in the mesosphere. Then sounding rockets and rockets powered aircraft reach this layer. Okay, so here we can see these sound rockets can be reached in the mesosphere as well. Then let me talk about the thermosphere. This thermosphere starts from 80 kilometer to up to 700 kilometer. And here the lowest layer in the thermosphere is the ionosphere. Why this is ionosphere? Because here there is a very high temperature, and the gases concentration is very thin. Gases are very much far apart to each other in such a way that a plasma like condition happens here. So the lowest layer is ionization, and this ionosphere can lead to the reflection of radio waves, and these can give us the error in the GPS signals as well, because whenever there is a charged particles or the charged gases, this will give some error to the waves that are being reflected and that are being going to the troposphere for our technology purpose and for our convenience. Okay, then here temperature increases with height. Why this is happening? Because here the gases are absorbing the ultraviolet radiation, the X-rays, every type of every type of radiation the gases absorbs here. Okay, that's why here the temperature increase with the height. Because at that height, uh, there will be rarely any water vapor or the cloud. So this thermosphere is free of cloud and water vapor. The very interesting terminology here is the aurora borealis and aurora australis. So these kind of phenomena can be seen in this layer. So what are these auroras? We will talk about in the next slide. This is very interesting, and one of the question in assignment has been asked about these, like where in which sphere the auroras can be observed. So this is in the thermosphere. Okay. So the next is, here is the International Space Station. So this kind of stations orbit in this layer. And I already have talked about it, because these layer have the positive charge, even has the negative charge. Because of the charges in the gases, radio wave gas deflected. This has been explained already. Now the exosphere, in the this exosphere start from the thermopause to around 1000 kilometer, and at the top it merge with the solar wind, because there is no more atmosphere. This is the one of the outer, exo means outer, this is the outer sphere within the atmosphere. Here the particle keep escalating into the surface, because here is a very less gravity. And we also know that the temperature also here is very high. Because of this, the particles keep escalating into the space, and most of the satellite orbits in this layer. So let's talk about what is aurora borealis and aurora australis. Before that, let me once again explain you that here in the troposphere, the temperature decreases with height. Then in the stratosphere, it increases with the height. In the mesosphere, it decreasing. And the temperature that is lowest is in the mesosphere, not in the stratosphere. So in the mesosphere, the temperature is the lowest. Then after this mesosphere, in the thermosphere, the temperature will increase with the height. And we already have talked about this, like in the stratosphere, in the mesosphere, this sounding rocket can happen. The meteors will be burned in the mesosphere. Then some auroras will be observed in the thermosphere. Let's talk about these auroras, what these are. So these auroras are the display of light in the sky predominantly seen in the high latitude regions. Means this type of display of light will be seen in the polar region. Either it is the northern polar region or it is the southern polar region. So there is a two type of auroras. First is the aurora borealis and second is the aurora australis. These will be observed in the northern hemisphere and this will be observed in the southern hemisphere. So here we can see borealis, boreal forest. You can relate it to the boreal forest because boreal forests are present in the higher northern latitudes. So this is in the northern latitude and this is related to Australia, Australis. So here it is, this display of light will be happened in the southern hemisphere. And what's the science behind their occurrence? Why there is a display of light in the sky? So the reason is that we have some electrically charged particle that has been trapped by the earth magnetic field, and these charged particles will collide with oxygen and nitrogen that is present in the earth upper atmosphere. Because of this collision, the light, because of this collision, it will make the gas molecules into the excited state, and whenever these excited state return into the normal state, it will emit some lights. Okay, so this is the reason behind it. The reason is just normally that the we have some electrically charged particles, mostly the fast moving electrons that are collided with the nitrogen and oxygen that are present in the atmosphere. And because of that, our gas molecules first will go in the excited state, and then it will return to the normal state. And when it will return to the normal state, it will emit some light. Okay, so here we can see the green light, here the red light. A very beautiful display of light is can be observed in the north polar region and the southern polar region. So they origin at the altitude of 100 to more than 400 kilometer. Okay, now the color of the aurora will depend on what the gases has been excited by the electrons, either it is oxygen or the nitrogen. The first, it will be the like what the gases it is. The second is how fast the electrons are moving, and third is how much energy they have at the time of their collision. So based on these three conditions, it will lead to the different color of the auroras. For example, if we have higher energy electrons that collide with the oxygen, then they will emit the green light. And if there is a low energy electrons that collided with the oxygen, they will give the red light. But if our gas in the atmosphere is nitrogen and it is colliding with the electron, it will give us the blue light. And because we have blue light, we have green light, we have red light, so blending of this light will lead to the purple, pink and white color. So and there is a very beautiful display of light we can see in the polar regions mostly. And whenever you will go to the Norway or the Finland, you can see such kind of display of light in such countries, because these are near to the polar region. Then what will be the impact of these auroras? These auroras affect communication line, radio lines and power lines. Okay, and here one thing that we should keep in mind, that this solar wind is behind the whole process. Why these electrons are moving that much fast, why there has been a collision between electrons and the gases in the atmosphere, because there is a solar wind that is pushing these gases, and that leads to the collision. Okay, so the solar wind is behind the whole process. So this is the auroras. Okay, so there has been some confusion about where the atmosphere ends. Okay, so two theories has been come up, and in one theory there is there is a Karman line. This Karman word has been taken from the scientist name. Okay, so this Karman line tells ki it is this Karman line is at the 100 kilometer above Earth's surface, and because the 99.9997% of the atmosphere lies between these lines, so that's why we can say that because most of the atmosphere lies within this, so these can be the end of the atmosphere. So this is the one location where we can say that above it there will be like no atmosphere. The second is geocorona. Geocorona is till 6 to 9,300 kilometer above Earth's surface, and here there is a no such gases like the CO2, O2, water vapor, nothing above this height. Above this there is only the cloud of hydrogen. So we can say that because we don't have that gases that are present in the atmosphere, so at that location the atmosphere ends. So this is the geocorona. Now talk about the composition of the Earth atmosphere. I think you people know about it, but yes, let me repeat it. We have the nitrogen gas. The percentage by volume is 78.084. This is the highest contribution. Then the second number is oxygen, that is 20.946. After that, there is a argon. Argon is the noble gas, that is very inert gas, just like the nitrogen gas. So argon, the percentage is 0.934. After that, we have the carbon dioxide 0.037. Then we have two noble gases or inert gases, that is neon or helium. After that, we have the methane and the kryptons. The uh, the most important thing that we have to keep in mind that these gases, either it is nitrogen or the noble gases like argon, neon, helium, and kryptons, they are not taking that much part in most of the activities that has been taken place within our atmosphere. But this oxygen, this CO2, and this methane has been fluctuating, and the fluctuation is because most of the activity involve this type of gases. And yes, I already talked about that anthropogenically modulating atmosphere in which this CO2 is increasing, and that's why this oxygen is being decreasing. So we will talk about it at the length in the later slide as well. So this is the composition of the Earth atmosphere. You must know the sequence of this, because in many in the net exam and in the some other exam as well, the question has been asked uh, about the sequence of the percentage of gases in the atmosphere. So you must know that before the CO2 there is the argon, and after CO2 there is a two inert gases, that is the neon and helium. After that there is also a methane gas, CH4, and at the end there is a noble gas. So you must remember the sequence of the percentage of gases by volume. If you have any question, you can raise the hand and you can ask me, you can comment in the chat box so that I can answer your question or your queries. So let's talk about the modulating component in the atmosphere. Within the atmosphere, we have some components that has been modulating the system. So what are these components? We have the water vapor, and we have the dust particle and salt. So these water vapors are also a potent greenhouse gases. Why water vapor is the greenhouse gas? Because it is a good conductor of heat, and it can absorb the radiation, it can absorb the energy from the long wave radiations. Water That's why water vapor is also a greenhouse gas. And because whenever the air rise and air is laden with the moisture, it can release the latent heat, and because of the condensation the energy get released. So the stability and instability of air is also dependent on the concentration of water vapor. Water vapor is highest in the tropical region, because in the tropical region there is the much heating as compared to the polar region. So from the ocean the air carries the vapor, and it goes up. So approximately 4% of the water vapor, uh, the contribution of the water vapor within the atmosphere can be go up to 4% in the troposphere and zero in the polar region. Then the dust particle and salt, because these particles can be act like the condensation nuclei on which cloud can be formed. So the cloud formation, rainfall, and then this kind of processes can be modulated by the dust particle and salt. Because this dust particle can scatter the light, can reflect the light, because of which the cooling and warming can be happen. So these are the modulating components. The one example of these being the modulating component is 65 million year ago, dinosaur extincted. Why dinosaur extincted? Because because we know that meteors collided with some sulfate rocks, and this sulfate rock had the gypsum in it. Because this gypsum will release in the atmosphere because of that high energy released while collision. So these energy will lead to the gypsum into the upper portion of atmosphere, because this gypsum as a dust particle will be there in the atmosphere, in the upper atmosphere. It will scatter the light, or it will block the sun radiation. After the blocking, the sunlight will be reduced, and if there will be no sunlight, then the death of the species can be happened. Okay, so these dust particle of the gypsum is also the one of the biggest reason why dinosaur extinct. Okay, so if you have any doubt, you people can tell me, and if you have no doubt, then let me please know that there is a no doubt, and I can proceed further. Khushbu has been gone. Kuldeep, there is any doubt? Okay, thank you. So let me proceed. Now let me talk about what is the source of energy in the atmosphere. We know that the ultimate source of energy is sun itself. So we have the insolation, that is the radiation that is coming from the sun to the earth. So we have the insolation, that is our source of energy in the atmosphere. But this insolation varies with the time of a day. Here we can see our earth moves from west to east, and when it moves, some portion of it get light from the sun, and some has the shadow region. So the insolation varies with the time of the day. Then it also varies with the season. Here we can see the season has been formed because of the rotation of the earth around this in the circle. So here we can see in the summer there is a different kind of insolation. In the autumn there is a different region that get insolation. In the winter there is a different region that get insolation. So the insolation, the amount of insolation varies with the season also. Then the location of the earth. If it is the equator, then equator will get the highest portion of the energy, because the radiation will go straight to the equator portion. But if we talk about the polar region, then we will get a very deficit light there, very deficit of energy will be happened there, because very less energy or very less insolation is reaching at the polar region. Then the angle of inclination, if the angle of inclination changed, then the amount of insolation will also vary. The next is transparency of the land. We already have talked about the dust particle, the aerosols. So these dust are, or the different type of gases. So different type of gases can absorb the insolation. The different type of aerosol can reflect or scatter the insolation. So based on the whatever the material, whatever the composition we have of the atmosphere, the amount of insolation that will enter in the atmosphere will be decided. Then the aspect of the land. What is the aspect? If you can see this figure, let's say this is the northern aspect and this is the southern aspect. Okay, and if we are talking about the northern hemisphere, see here is the northern hemisphere. In the northern hemisphere, if we have the southern aspect of the mountain, then here we will get more sunlight as comparison to the southern aspect of the mountain. but this will be reversed in the case of the southern hemisphere. So aspect of the land will also decide the amount that will get of the insolation. Then the position of earth with respect to sun, if it is away from the sun or it is near to the sun. If it is near to the earth, if it is near to the sun, then this condition is perihelion. And if the sun is farthest from the earth, then this condition will be aphelion, and this will also decide the amount of insolation the earth is getting. Then the amount of energy being released by the sun. So, because we know that we have the solar cycle, and because of that solar cycle there is some magnetic activity within the sun. Because of this magnetic activity there is a sunspots on the sun, and the energy uh, the energy varies with the number of sunspots on the sun itself. Okay, so it is solar cycle, and it can be sun that our earth get a different and get the variation of energy from the sun. Then how this, if we have the energy, we have, if the sun radiation is entering in the earth atmosphere on the earth surface, so how this energy moves within the atmosphere. So there are four processes, or you can say the mechanism by which energy moves within the atmosphere. These four mechanisms are conduction, convection, advection, and radiation. So let me talk about it one by one. If we talk about the conduction, then there must be a touch. This is the touch mechanism. If there is a heat, if an object touch this heated object, then the energy will be transferred. So heat is transferred to that part of the atmosphere close to the hot surface of the earth. So here there should be the contact between two objects, so that the heated object can give the energy to the another object. So here is the conduction. And because we know that air is very bad conductor of heat, so conduction can't be go to the longer distance. So we must have some another kind of movement in the atmosphere. The second is convection. In the convection, what happened? We have the heated air, and this heated air expand and rises up. So air get the energy. So we have the energy within the air molecules, and after getting the energy, they will rise, they will expand, and they will sink or subsidize. So this is the convection. The next is advection. Here is there has been a horizontal movement of the wind. So the energy is carried by the horizontal moving wind, and uh, so horizontal transfer of heat by wind is happened in the advection. If we talk about the radiation, so heat is transferred from the surface of earth to the outer space in the form of the long wave radiation or the short wave radiation. So and these can move within the vacuum as well. So in the form of electromagnetic radiation the energy moves. So this is the radiation. Here we can see the electromagnetic radiations. This is the radiation. Then if the air molecules get the energy and they rise up, this is the convection. If there is a direct contact between two objects, the one is heated, then the another object will get some energy. After a direct contact, then this will be the conduction. And if there is the horizontal movement of winds, then this wind will carry the energy forward in the direction of the wind itself. So this will be the advection. Let's talk about the budget of the earth. Budget of the earth says that whatever the amount of solar radiation we are getting in the atmosphere, the equal amount must be escaped into the into the outer space. Why there should be net zero radiation? Because so if it happens that there is a less energy that is going outside, so constantly it will rise the temperature of the earth, and earth temperature will constantly rise. So this can't be happened. If there is a energy that is going more than the incoming energy, then earth will cool itself continuously. So earth is neither cooling continuously, neither heating continuously. So because the incoming solar radiation is equal to outgoing solar radiation as well as the long wave radiation. So here we have the 100% incoming solar radiation, out of which 26 are reflected or scattered by the clouds, and 4% is reflected by the Earth's surface. So the 30% of the solar radiation has been escaped into the outer space, and the nature of these radiation is short wave. These are the short wave radiation. Okay, so because we have like 30% radiation has been escaped into the outer space, now the remaining is the 70%. So these 70% in the long wave radiation. Why I'm talking about this short wave radiation and long wave radiation? Because whenever sun radiation is entering into the atmosphere, this will be the short wave radiation based on the temperature of the sun, because the temperature of the sun is approximately 5 or 6,000 Kelvin. So that's why, because of the high temperature, it will give the short wave radiation. But we know that the average temperature of the earth is 15 or 16 degrees Celsius only. So it will give rise to the long wave radiation. You must have studied about the wind displacement law, which says that temperature is inversely proportional to the wavelength of the radiation. If temperature is higher, then it will give rise to short wave radiation. The wavelength of the radiation will be low or the less. And if we have higher temperature, then it will give rise to the longer wavelength radiation, that is long wave radiation. So 30% radiation has been reflected in as a short wave radiation itself, but 70% has to be escaped into the outer space in the form of long wave radiation. So after the greenhouse gas, after the back radiation, after the latent or sensible heat, the 70% radiation get returned to the outer space. So this is the heat budget of the earth. If we talk about the temperature and its distribution, then we know that the air temperature at a place is dependent on the latitude of a place. Why the latitude of the place? Because here we can see, here is the zero latitude, and this is the northern pole, here is the southern pole. So at the zero latitude, means at the equator, we get higher net short wave radiation, and ample amount of short wave radiation we get at the equator. But we reflect or we return the energy in a long wave radiation that is less than the amount of short wave radiation. So here is the surplus of energy. But if we see in the polar region, we get less amount of short wave radiation, but the outgoing radiation is the amount of outgoing radiation is higher. So here is the deficit of the energy. So because here is the surplus energy, the temperature will be higher here. in the deficit region, the temperature will be cooler. So air temperature is dependent on the latitude of the place. Second, it also depend on the altitude of the place, because we know the lapse rate, with the height, the temperature decreases. Then the distance from sea, because sea has the modulating effect. Sea tries to balance the temperature of the atmosphere. It slow down the rate of changing the temperature. That's why the distance from sea also is an important factor on which the air temperature depends. Then the air mass, we will talk about air mass in next slide. Then the oceanic current, if there is a two type of currents, that is cold current and warm current. If there is a warm current, then obviously above it the air temperature will be warmer. But in the cold current, then the air temperature above the cold current will be cooler. So this is very obvious. And we already have talked about the aspect. There is some local factor. If there is a shadow on which, in this factor as well, our air temperature will be dependent. Okay, because we have the variation in the atmosphere. Let's say in the equator there is a higher temperature, in the polar region there is a less temperature, and because here is the energy deficit, here is the surplus energy, and we know that our climate system want to maintain a equilibrium condition. So how can it maintain the equilibrium condition? It will transfer some energy from this surplus to the deficit, so that equilibrium condition can be taken place. So that's why here is the atmospheric circulation. So what is atmospheric circulation? It is a mechanism to redistribute the heat on the planet. It ensures that equatorial region do not get overheated, and it also ensures that polar region don't get the low heated, and excess heat can be shifted towards the poles. So this is the circulation. Here in the circulation, the very basic thing is circulation is the mechanism that redistribute the heat on the planet. And how it can redistribute the heat on the planet? So here is the factor, that is the atmospheric pressure, that is important for the circulation. So what this atmospheric pressure does, it drives the movement of air that causes wind. So let me talk about what the atmospheric pressure and why we measure it into mm of mercury. Here is the experiment that was done. In that experiment, we had a bowl full of mercury, and with this mercury we have the inverted tube that was also full of mercury, and if we invert it, a vacuum has been created here. And whatever the length of this, the height of this, before the vacuum will be, it will show the atmospheric pressure. So the atmospheric pressure that was measured was 760 at sea level. So from there only we could measure the atmospheric pressure. So let's talk more about the atmospheric pressure. The atmospheric pressure is caused by this is caused by the hydrostatic pressure, and this hydrostatic pressure is being created by the weight of air that is above the point of measurement, and this is also modified the planetary rotation, local effect, etc. And the unit of this pressure is either Pascal or the Newton per meter square. Actually, Pascal is also equal to Newton per meter square, then mm mercury and bar. The standard atmospheric pressure we have is 101,325 Pascal or 760 mercury or 1 bar. And if there is a pressure difference, then air will move. Means a wind will because we know that air movement is known as wind. So wind will blow if there is a pressure difference. And the formula of pressure is height. Rho is the density, then g is the acceleration due to gravity. So atmospheric height multiplied by the density of air multiplied by the acceleration due to gravity, that is h rho g, is the pressure formula. Okay, so because of pressure difference, air moves, and air moves is known as wind. Okay, but wind has two characteristics, that wind has a direction, and direction can be measured by the instrument that is known as wind vane, and wind also has a speed, and this speed can be measured by the instrument anemometer. Okay, and always the wind moves from high pressure area to low pressure area because there is a deficit of air. Here is the rich air, so the air will try to move to the low pressure region. So this is the direction where the wind moves. Okay, so based on the type of winds, sorry, based on the speed of the wind and height of the wind, we can we can tell about the land condition. And this has been there is the Beaufort number starting from 0 to 12, based on which we can tell about the speed and then the land condition. If it is a zero means if we have 0 meter per second speed of the wind, then the land condition will be calm. The smoke, and this is just like the smoke rises vertically. If there is a calm air, these wind type is dependent on the wind speed only. So if there is a light wind, then wind motion will be visible in the smoke. If it is a light breeze, then the wind felt on exposed skin or leaf rustle. So I don't think that I need to repeat it, because as the wind speed increases, it will evident the land condition in a very significant way. So, for example, if it is a Beaufort number 12 and the wind type is hurricane force, here the wind speed is very high. And because whenever we talk about the speed, we know that there is the kinetic energy, and this kinetic energy will act as a force and will damage the building, whatever whatever the thing in front of that wind. Okay, so this is the Beaufort scale chart. Okay, then let's talk about the vertical distribution of air pressure, because we know that there is a whenever we have the heated surface, then the air will be warmed, it will rise above, but if it rises at the height, it expands, and uh, air after expansion it cools down. So why this is expansion is taking place? Because at some height there is a air pressure that is low, but at the bottom of the atmosphere there is a high pressure. So if we want to know the pressure at any given height, so here is the formula says P, that is the pressure at that height, is equal to PB, that is the reference pressure, let's say the mean sea level pressure, multiplied by TB. TB is the reference temperature of that pressure reference pressure place, divided by TB. plus LB. LB is the lapse rate. I already have mentioned about what is lapse rate, multiplied by H minus HB. Here H is the height at which pressure is calculated and HB is the height at the reference level, and it is 0 in the case of mean sea level pressure. Then these equation is raised to gm upon RLB. So G here is the acceleration due to gravity, m is the molar mass of the air, and the value of this is given here 9.8 and 0.02896 kg per mole. And here here R is the gas constant and LB is the latent lapse rate. So based on that, we can estimate what will be the pressure at any given height. So okay, now because we have higher pressure at the bottom and low pressure with some height. So, in spite of this vertical pressure gradient, why doesn't air move from ground to above ground? Okay, so why this wind moves vertical in the horizontal direction? Why this is not significantly? Why air not significantly moving from ground to above ground? Because these force is balanced by the gravitational pull of the earth. That's why we this vertical distribution is of not that much significant as we talk about the horizontal distribution. So horizontal distribution is very important for us for many events and the phenomena. So how this horizontal distribution of air pressure happens? Let's say here is the 500 MB millibar of the air pressure. Here it is 512 millibar pressure. So we know that it is the low pressure and it is the high pressure. And we also know that the movement will be happen from high pressure to low pressure. Okay, so the wind should be moved from here to here straight. But why this is not happening? Because there are some factors that is affecting the wind velocity and direction. What are these factors? These factors are, the first is Coriolis force. We will talk about this Coriolis force in next slide. Then it deflect winds toward right in northern hemisphere. As we can see, if there is a wind moving in this direction, it will deflect in the right side in the northern hemisphere. This will be clear in the next slide. Then we have the gravitational force, and then we have the frictional force. This frictional force is very negligible over the ocean and sea, but it will be important up to 3 km, because we have surface that is very rough. In the rough surface, the frictional force will be significant, but if it is a smooth surface, then frictional force will not be very much significant. So this is the geostropic wind that moves within this uh, within this isobars. What this isobars is, the equal pressure lines we have. Let's say this is the line where the pressure is 500 MPa. Okay, so these are the isobars. So horizontal distribution of the air pressure is represented through isobars, and these are the factors: Coriolis force, gravitation, and frictional force that give rise to the deflection in the direction or affect the wind velocity. So let's talk more about this. What does this Coriolis force? We know that Earth moves from west to east. Okay, so the our reference frame is moving from west to east, and if our wind wants to move from south to north, what will happen? Because our reference frame is moving in this direction, west to east, so our wind will also be deflected in this direction. So in the northern hemisphere, the wind is deflected to the right side, and because we know that uh, because our earth is moving west to east, so that's why it is also move this side. So this will be the left in the southern hemisphere. So because of the Coriolis force happened due to the rotation or the movement of the reference frame. There should be the reference frame that is being rotating, the first condition. The second condition, some wind will be moving. Okay, so when wind will move, it will be deflected. So it will deflect to the right in the northern hemisphere, but if we talk about the southern hemisphere, it will deflect to the left. In such way, we can see here, if the direction is from 30 degree to equator, then it will move in this direction, left side, because it is moving from here to here. So I think this is clear why this deflection is being happening, because this is due to the Coriolis force, and because of this Coriolis force, our wind direction is also changing. Okay, let's talk about what is air mass and what is fronts. We know that there is some homogeneous region. Homogeneous region means there is no variation on the Earth's surface. For example, if we have an ocean, because ocean surface is very smooth, so uh, at a longer distance, it create a homogeneous region. So above this homogeneous region, there will be high body of air, a large body of air, because suppose there is an ocean, then there will be the air above this ocean layer, and this wind will have some property of the ocean itself. And if there is no movement of air, if air is still, then at a longer time, these large body of air will be there only. Okay, so and let's see the definition of air mass. Air mass is extremely large body of air whose property at any given altitude are homogeneous over a large horizontal area in any horizontal direction. So what are the conditions when this air mass will be formed? The first condition is area must be large and there must be uniform surface composition. Okay, if there will be like roughness in the surface, if there will be some mountains, if there will be plain area, then there will be some movement of the air, and this movement of air will not let the large body of air be present there only. Okay, so that's why there must be large and uniform surface composition there, and there should be no wind or very little surface wind. Then this will create the air mass. For example, in this ocean, we can see this is the air mass. This air mass means this air have some characteristics of the ocean, and that will be present above the ocean for the longer time. Okay, so these are the air masses. So we can classify into the polar or tropical. If there is, if this air mass is present in the tropical region, then we will call it the tropical. And if these air masses are present in the polar region, then we will call it a polar, P. Again, it can be divided to continental or marine. If the air mass is present in the continental or the land mass, then it will be the continent. If it is present in the marine area, then we will call it the M. Okay, so here we can see, if it is a CT means continental and tropical. So here we have the continental and tropical kind of air mass. And because we know that in the marine system we have water, So here will be, here the air mass will have the moisture, but in the continents the air will be dry. Air will be dry. In the tropical, the air will be hot, but in the polar region, the air will be cold. Okay, so we can, if it is a CP, means if the air mass is at the continent and at the polar region, then this air mass will be generally cold and dry. If it is in the continent and in the tropical region, then it will be hot and dry. Same if it is in the marine system, if it is in ocean, or it is in polar region, then it will be, because of being in the polar region, it will be cool, and because of the marine, it will be moist. If it is marine and within the tropical region, then it will be the warm and moist. So here we can see, here this A is Antarctica region. Okay, if you are not understanding it, so here is Antarctica, here M means equator. M means equator. So we can see there is a large number of air masses we have on our earth, in our atmosphere. So when this air mass is, suppose we have this air mass and we have this air mass, when the wind blow, these air mass can come close to this air mass and they can collide each other. They can confront each other, and when they approach each other, the transition will known as the front. Uh, So here we see there is a different type of air mass: the marine equatorial, marine tropical, the continental tropical, the marine polar, the continental polar, and then continental Arctic and Antarctic. And based on this, because I already told you that there is some characteristics of air mass, so the temperature and the specific humidity can also be defined based on the air mass. I also mentioned that characteristic of air mass is determined by the characteristic of the surface over which the air has been lying for a long period of time. If we talk about the fronts, as I already told you, that these are the transition zone between air masses of different properties. So if there is the air, two different air masses uh, that are approaching each other, so whatever the transitional zone will be created, that is known as the fronts. So there are four type of fronts. In the cold fronts, the cold air mass will push the warm air mass. And if it is pushing the warm air mass, the warm air will go up to the cold air mass. So this is the cold front. If we talk about the warm front, here the warm air mass will push the cold air mass. Even after the fate will be, warm air mass will go up to the cold air mass. So this is the, but here we can see the boundary of the air masses. Here it is very gentle and here it is a steep. Then we have stationary, when there is a no movement in the air masses. Here it is a warm, here is the cold, and there is a no movement. Then it will be the stationary front. Then the fourth is occluded front. What happened in the occluded front? There is the cold mass here, and in between that there is a warm air mass. In such a condition, there will be front that is known as the occluded front. This occluded front can be classified into two types. The one is cold occlusion, the second is warm occlusion. What happened in the cold occlusion? Here is the coldest air, and here is the cold air, and here is the warm air. Okay, so because here coldest air is pushing the warm air will go up, then it will push again the cold air, because coldest air will sink below. So this cold air will go also up, but this coldest air will be sink. So this is the cold occlusion. But in the warm occlusion, here is the coldest air and here is the cool air. So cool air will push the warm air because there is the comparison, there is the gradient between cool and warm. So warm air will go up, but this is the coolest air. So this cool air will also go up on this coldest air. So this is the warm occlusion. So these were the fronts and the air masses. I think it is clear. Is everyone, is any Kuldeep, is it is clear what is air mass and what is front? Kuldeep, are you here? Okay, thank you. So air mass and front has been cleared to you. Now let's talk about the general circulation of the atmosphere. So the general circulation I already mentioned you. This is the mechanism by which energy is being transferred from high pressure area to low pressure area. So the general circulation of atmosphere is governed by the latitudinal difference in energy surplus and deficit. So if there is the latitudinal difference in the energy, in the one place there is the surplus, in the another place there is the deficit. So this will create the this will be the one factor that will lead to the general circulation. Then second is the emergence of pressure belt as the result of convection and subsidence of air, because air is being rising. Air after rising it expands, after that it sinks. So the rising of air, the phenomena is convection. So because of the convection and subsidence, there is the pressure belt that will be created, and based on this pressure belt the general circulation will be happened. Then because of seasonal changes, the pressure belt also migrate. For example, here we can see we have the ITCZ, intertropical convergence zone. In the monsoon time, the convergence belt, like this is the low pressure belt. So this low pressure belt will be in the northern side of the India. But in the winter time, this low pressure is shift to the below to this Indian continent. Okay, so because of this, because due to the seasonal change, pressure belt also migrate, and this also lead to some variation in the circulation. Then the distribution of continent and the ocean, as it obvious, because the heat capacity of ocean is very much different from the continents. Based on that, the distribution of ocean and continent will also govern the general circulation. Then the rotation of earth is very much related to the Coriolis force, and this Coriolis force will also govern the general circulation of the atmosphere. So let's talk about different type of cells that has been formed in the general circulation. So basically, three type of cells are formed. The one is Hadley cell, the second is Farrell cell, and third is polar cell. So what happened at the equator? Because we know that the highest energy is striking at this equator region. If there is the highest energy that is coming to the equator, the air will be heated here. Okay, and if it is heated, it will go up. If it will go up, okay, then it will, after going up to the certain level, the air will be cooled. Okay, after cooling it has to sink, so it will move either in the towards the north pole side or the southern pole side. Okay, so it will move in both direction and will sink. It will sink near to the 30th degree north. Okay, so after sinking, because the air is cool and it is coming down to the surface, it will create the high pressure high pressure, because here it is a air rich region, and because air has been gone up, so it will create the air deficit region, air at the equator. Because here it is the rich region, it is the higher pressure zone, it is the low pressure zone. So from the higher pressure to low pressure, air will air will move. So this is the so there will be a kind of circulation will happen between the 0 to 30-degree north and 0 to 30-degree south. So this kind of circulation that is being happening is the Hadley cell. Okay. Then we also know that at the polar region there is a very cool air. So based on that, we can say that here we have the low, here at the 60-degree, we have warm air as comparison to this polar region. Okay, so if it is the warm region, then it will also rise. After rising, it will sink towards the pole side or towards the equator side. And after sinking, here it will be the high pressure zone, here it will be the low pressure zone, and this the movement of air will be happen from high pressure to low pressure. So here also a circulation has been formed, and this circulation is the uh, polar cell. Okay, and if we talk about, because it has been the low pressure region, it is also the low pressure region. We also know that this has been created as the high pressure region. So there will be a circulation that is known as the Ferrel cell. Okay, so the three kind of cell that are being formed: the Hadley cell, the Ferrel cell, and the polar cell. And try to keep in your mind that it is the low pressure zone, then the high pressure, then low pressure, high pressure. There is the alternative. So, and we also know that from the high pressure, the air will move. So if it is moving from high pressure to low pressure, but because we also know that in the northern sphere the wind deflect in the right side, so wind will deflect and it will change the direction. So here it is coming from, it is seeming like it is coming in the west side. Okay, so and these movement of air from high pressure to low pressure, from here as well, high pressure to low pressure, this will create the trade winds. So these are the winds that are moving uh, around the ear. So these are the trade winds. We also know that here is the high pressure zone, and here it is a low pressure zone. So from high to low, it will move and it will deflect in the right side. So this will move in this direction. These are the westerlies. Same here, these are the westerlies. If here it is a low pressure zone and there is a high pressure zone, so wind will move from high pressure to low pressure, and these are known as the polar easterlies. So in the journal circulation, we have two things we have to keep in mind. We have three cells, that is, one is Hadley cell, the second is Ferrel cell, and third is polar cell. And because of this circulation, the wind will move. So whatever the wind is moving from 30-degree to 0-degree, it will be the trade wind. Whatever the wind is moving from 30 to 60, it will be the westerlies. And whatever the wind has been moving from 90-degree to 60-degree, it is the polar westerlies. And this wind moves around the ear. Okay, so this is the general circulation. Because we have talked about the general circulation, and I already told you that these winds are permanent kind. These are moving around the ear. So so these winds are called invariable wind. So in the invariable wind, we had the trade wind, we had the westerlies, and we had the polar wind. But if we talk about the variable winds that are not permanent, so in that wind, we have the seasonal wind and we have the local winds. In the seasonal wind, thus because of some seasonal changes, in only the some specific season the wind comes and return to somewhere. So these are the seasonal, and because of the some local factors a local wind forms. So let's talk about this and more. So seasonal winds, these winds change with the season, and because of changing in the season, the region of maximum heating is also being changes. The pressure belt is also shifting. The wind belt is also shifting. So because of this shift due to the season, these generate the seasonal pattern of the wind movement. For example, monsoon of Southeast Asia, because of the movement of ICTZ, whatever I already discussed that, because of creation of low pressure and high pressure, we get the monsoon in the Indian continent. So this is the example of seasonal wind. If we talk about the local winds, then there are the three characteristics of the local wind. That is, they are formed on a very small spatial scale, like from few kilometer to hundreds of kilometer in horizontal extent. So here they are formed on a very small spatial scale. Then these are formed for a very short period of time, from hours to days, and these are formed due to local conditions. So we can also classify these local winds into two types: periodically winds and the non-periodical winds. In the periodical wind, we will talk about land and sea breeze and mountains and valley wind. And in the non-periodically that are present during a season. So here we have the hot wind and cold wind. Here we can see this Mistral, this Levanter. So these are the cold winds that are coming mostly from the polar region. And we also have the hot winds, Chinook. Here it is a Chinook. Then the Santa Ana and Lu. Lu is also happening in the desert area of our Indian continent as well. So let's talk about periodically winds. So we have sea breeze and land breeze. In the sea breeze, what happened in the uh, warm air in the daytime? Warm because we know that continent get heated faster than the sea. Okay, so here the over the continent air will be warmed, and here the ocean will be cooler, because ocean take longer time to warm. The process of heating and cooling of sea is slower than the continent. Okay, so here it is warm air. Here it is a cold air. Then the movement of air will be from continent to sea. And because air heat the warm air is transporting away from the continent, it will create the cooler condition on the land. So that's how the warming condition is being modulated by the nearby sea, and this is the sea breeze. At the night time, because the continents get cooler very rapidly, but here the sea is warmer, because it took long time to warm, and it will also took long time to cool as well. So the direction will be, because here it is a warm air, it is a cold air. So uh, it will it will lead to the normal condition in the continent region, because it will not lead to the minus temperature in the continent region. So that's why the sea is the modulating component as well. So this is the land bridge. It is happening in the daytime, it is happening in the night time. So this is the sea bridge and land bridge. If we talk about the wind, valley wind and mountain wind, what happened in the daytime? The air rises. So this is an air rises with the adiabatically, without losing the heat. And so this is the valley wind. And if at the night time the wind will sink and will come down the slope, so this will be the mountain range. This so the slope will be cooled by the terrestrial radiation, and here the slope is being heated by the insolation. So these are the periodical winds. Okay, so next let's talk about the cyclones. In the cyclone, there is a two type. One is the tropical, and second is extratropical. Here we only talk about the tropical cyclones. So what are these tropical cyclone? For that, there are five conditions that must be met before the formation of the tropical cyclone. The first condition is there must be a warm tropical ocean, and the temperature of that ocean must be greater than 27 degrees Celsius. The second is there must be Coriolis force. The region must have some Coriolis force. Otherwise the air will not be deflected, and there will be no tropical cyclones in that region. The third, there should be little or no variation in the vertical wind speed. Okay, so this is the third condition. The fourth is upper divergence over the sea level system, and fifth is the facilitated by pre-existing weak low pressure zone. So there must be a a weak low pressure zone as well in that area. So these are the conditions that should be met before the formation of the tropical cyclones. So tropical cyclones are powered by the energy that are being released by the condensation of water vapor in the clouds, and this cyclone is powered by warm seawater, and these warm seawater after rising lose the energy upon landfall. So whenever the cyclone is approaching the land, so it will lose the energy. The warm, moist air spirals rapidly with the speed of 250 km per hour around a central eye. Central eye will create the low pressure zone. So, and this will form a large circulatory system up to 1200 kilometer in diameter, and upon rising the cloud forms and torrential rain can be occurred. So this is about the tropical. So there must be an eye, which is the low pressure zone. There must be a Coriolis force. Because of that the air will be deflected, and there also must be moist air, and moist air can only be present in the ocean. So in the ocean the cyclone forms, and it approaches the land area, and whenever it approaches the land area it loses its energy. So the question is why are tropical cyclones not formed near the equator? And the reason is because Coriolis force is zero near the equator. There will be the no deflection of wind will happen at that region. So we can say from here 5 south to 5 north, there is a no tropical cyclone, hurricane, or typhoons. Because if there is a no Coriolis force, thus the wind moves from high pressure to low pressure area, and this low pressure will get filled. There will be no deflection, there will be nothing because of zero Coriolis force. Okay, so we have already talked about the general circulations. We already have talked about the atmosphere. Okay, so the next and final part is climate and climate change. What is climate and what is happening with the climate change? So let's talk about the difference between climate and weather. So if we talk about the climate, it is a broad composite of the weather condition of a region. For example, if we are saying that in our region, let's say in the Madhya Pradesh, the temperature, the average temperature is 25 degree. Okay, so this thing you are talking about is climate. But if it is raining in MP in a one day, and so you are talking about the weather. Okay, so in the tropical, we are talking about the average condition of a region. And in the terms of, because we know about temperature, amount of rainfall, snow, so we talk about the climate in these variables. And because we are taking the average conditions, so there must be at least 30 years of which we are taking the average. So one question in the assignment is related to this 30 years. So for how much years we take to take the average of the to take the average condition of the region. Then we have the weather, the short-term conditions of the lower atmosphere, including temperature, humidity, precipitation, etc. So in the brief, we can say climate is what you expect and weather is what you get. So if we talk about, like, if we are in India, we can expect that here the climate is tropical. Tropical means here we will have like the warm condition. Okay, so this is climate. If we go to the Norway, then we will say that it is the cooler region. Okay, so and we also have to carry some like winter clothes. So this is, we are talking about the climate. But if it is a raining today, and the information we are telling that it is raining today, that it is weather, because weather is what you get, but climate is what you expect. uh, so let's say here it is an example. If it is a rain in a day, then this is weather. If we talk about like this is a tropical climate, then it is a climate. Here in this example, this is a beautiful example I got from the NOAA website, where it tells, like, weather tells you what to wear each day. Okay, because this is the short information. And what type of clothes you must have in your closet, this is climate. Okay, so I think it is clear what is weather and what is climate. So we are talking about, not about the weather, but the climate here in this session. Okay, so we have five components of the climate system. The first is atmosphere, the second is biosphere, the third is lithosphere, that consists of that land. Then we have the cryosphere, and then we have the hydrosphere. This is the one extra sphere that we have got, that is the anthroposphere, human modulated sphere. Okay, so these are the five components. And if there is a change in the uh, average, because we already talk about this now, a broad composite of average condition. If this average condition is getting changed, then we can say that the climate is changing. Okay, so what, whenever the changes is happening in the average climate, that will lead to the changes in the component of the climate system as a response. So let's see, what is the climate change? Climate change is statistically significant variation. It should be not like that from the 3 year there has been warming. We will not say it the climate change, because for the statistically significant means we must have a longer time period, in which period there is a warming. So the first thing, that there should be the statistical significant variation in either mean state of the climate. For example, once our average temperature was 25 degree, but if I say that now the temperature is 30 degrees Celsius, so the mean state of the climate is changing. So this is the first case. Second, if the variation is happening in its variability and it persists for an extended period. So for example, if we talk about the uh, precipitation extremes. Okay, precipitation extremes means we are not talking about the mean state of the precipitation. We are talking about the extreme case of the precipitation. And if it is like if precipitation extremes are increasing or decreasing, then we are not talking about the mean state, but we are talking about the variability of the variable. So this is the second case. So for the climate change, there should be significant variation either in the mean state or in the variability, and this is for this should be persist for an extended period, then only we will say the climate is changing. And what are different forcing or drivers of the climate change? So we basically divide into two parts. The first is natural variability and second is external variability. So in the natural variability, we have continental drift, we have oceanic current, we have earth axis tilt, volcanic eruption, or celestial object. It means the climate is changing by these things, and these things are happening itself, like there is a no interference by the humans. Then it will be the natural factors or natural drivers or the natural forcing that causes the climate change. Then second, we have the anthropogenic factor, in which we are doing agriculture because of urbanization, because of change in land use, because of deforestation, the climate is changing, and so this is the anthropogenic or external forcing. Because of these forcings, okay, let me more talk about this natural forcing. So here we can see the orbit was like this. Okay, after some year, after thousands of years, the orbit shape can be like this. Okay, so this will change the insolation. This will also may change the climate. So the climate change can be happen because of this changing in the orbital shape, and this is known as eccentricity. If the tilt of the earth is changing, because it changed from 21.5 degrees to 24.5 degree, it rotates. Okay, rotates around its axis. So it is the tilting of the earth axis. So if this is happening, this will also lead to the change in the climate. Okay, so it also take thousands of years. And if we talk about the precession, because of the season change and because of the rotation of the earth, the region that are getting insolation get changed. Okay, so this is known as the precession. But the point is that these are taking thousands of years, but whatever the climate change is happening, it is happening rapidly. So what can be the reason? So these natural forcing are causing the climate change, but these are not very significant right now. And the reason is we, the human, are making the climate change. Okay, so we talked about the natural forcing and the external forcing. Because of this external and natural forcing, it will these forcing will give some responses. And to whom it will give some responses? It will give responses to the climate system components. And after give some responses, what type of responses these forces will give? It will either change, we already talked about this, the component of climate system. So the forcing will change the state or change, will give some variability in this climate system. It can be the ocean acidification can happen, air pollution can happen, deforestation can happen. So these components will get a response due to the forcing. Okay, so we had a forcing, from the natural or human activity, we had the forcing. These forcing will give response to the climate system components, and these response will have some impact, and this climate response will be in the form of changing the temperature, changing the precipitation, and changing the vegetation. Okay, so let's talk about what will be the impact of these responses, and what are the different kind of responses we get due to this kind of forcings. So we have biological responses. So in that biological responses, we have the genetic. In the genetic, we have like alleles variation, mutation, or the natural selection. For example, if because we have a different color of the hairs we have. Okay, it can be black, it can be gray, it can be white, and it can be burgundy. So multiple color of the hairs we have, but it can be that some kind of colors get finished or get depleted in such a way that the natural selection only select the black color of our hair. So this is the genetic response, and this can be happen due to the climate change. uh, for example, if we take like, if we have polar bear, why there are polar bear in the polar region? Because they are white in color. Okay, and they can hide themselves in such a way that they can attack on the prey. Okay, so if the ice is melting, if the glacier is melting, it will create the snow will be melted, so the surface will be dark in color. So if it is dark in color, then polar bear can be seen by the praise. So praise will be very alert. So in such a way, the polar will be extinct, or the color of the polar will bear have to be either changed, or the bear will be extinct. So this is the genetically response of the biological organisms. The second is physiological. It may be that the respiration or the photosynthetic activities or the rate of these activities is being changes because of the forcings, because of forcings. Okay. Then we have the phenological. What is phenological? Phenological is the growing season of the vegetation can be expand, can be shortened, or if the flowering was happening uh, in the suppose in March, it is happening in the February because of warming, because the growing season has been expanded. So the dying of the leaf, the budding, the flowering, these type of events has been changing. So these are the phenological. Then the population dynamics, the sex ratio, the age structure can be changed. Then the distribution, the habitat quality and quantity, and the range size can also be changed because of the external and the internal forcings. Then we have the interspecific relationship. For example, if some invasive species or the alien species come in the India, so it may be happened that it destroy all the native species. And if it is destroying the native species, then the relationship between the species will get changed. So this is the interspecific relationship. Change in the synchronization. If the one bird is laying egg in a climate in such a way that that there is a tree, and tree is giving the fruits, so that the bird can get the food at that time. So this is kind of synchronization. Whenever the tree is giving the fruit, only then the bird will be breed. Okay, so this is the kind of synchronization, and this can be changed, or this can be this can be damaged. Then the coupling and uncoupling and new interaction. As I already told you, that if there is an invasive species, so because of that invasive species, new interaction can be happen, or some existing interaction can be ended. Okay, so this is the coupling and new interaction. Then we have the community productivity. So the biomass quantity, the energy and matter flux, these can also be changed. So these are the biological response. The next are ecosystem services. If we talk about the composition, function, and production of the forest, these the change in these services are also the biological responses. Then the next is biome integrity. So the frequency in the catastrophe or change in the resilience or desertification is happening, then there is a biological response in the form of biome integrity. Okay, so if there is a climate change, then we must have some strategies against this climate change. So basically, we have two strategies. The one is mitigation, and the second is adaptation. If we want to reverse the climate change, okay, if we want to control the warming of our temperature, then we are talking about the mitigation. If we don't if we are not worrying about the controlling the temperature, but we want to reduce its impact. Suppose if temperature is increasing, we are just buying the ACs in our home, so that the impact of this increasing temperature doesn't affect us. Okay, so this is kind of adaptation. So mitigation is a human intervention to reduce the source. Either it will reduce the source of emission, or it will create some sink. For example, either it will create some technology, or it will improve the technology in such a way that we need a very little fossil fuel for the vehicles. Okay, so we are reducing the source of greenhouse gas here. And if we are suppose increasing the forest area, then forest will absorb this CO2, then we are increasing the sink of this greenhouse gas. So this is kind of mitigation. If we talk about the adaptation, then we are adjusting ourselves. This adjustment can be happened this can be happened due to the climate change, or we also can think that yes, climate change will happen. So before that, we know that climate change will be happen. So in the expected climatic stimuli as well, we do some adjustment in such a way that we don't have the harms. We can manage ourselves in the increasing temperature, or let's say in the drought condition. So we are exploiting the beneficial opportunities. Okay, so these are two kind of strategies. The one is mitigation, and second is adaptation. And in the adapt and there is some kind of sync between this mitigation and adaptation as well. For example, if we are increasing the urban green areas, so that we can have shadow area, and we are reducing the impact of high temperature. Okay, but this is also the mitigation, because we are creating the sink of greenhouse gas. So there is some common factors among this mitigation and adaptation. So these are different strategies, different mechanism within the mitigation and adaptation that we can adapt. So what are the mitigation option? uh, in the mitigation option, I already told you that either we have to reduce the emission, or we have to create the sink. If we want to reduce the emission, then we have to rely upon the some laws will be created in such a way that technology can be improved, or in such a way that like the odd and even strategies that happened in the Delhi, in which so that uh, a small number of vehicles can come out in the city. So such kind of laws can be framed to reduce the emission. Then the green energy. if energy is being extracted from the in the green in a sustainable manner. Okay, if we are not getting the energy from the fossil fuel but from the, let's say, the hydrogen cell. Okay, so this kind of green energy can also reduce the emission. Then we have red means reducing emission from deforestation and forest degradation. If we are not doing the degradation, and if we are not doing the deforestation, then we are reducing the emission. Then creating sink, how we can create the sink, how the greenhouse gas can be stored. So the one is artificial trees. We are growing the trees, we are planting the trees so that a sink can be created. Then we have some geological sites in which the mining has been happened earlier. So in the mining area, there has been some calcium carbonate stones or the rocks. So in that mining area, what we can do is we can store the CO2. Okay, so here the because of there is a carbon dioxide, calcium carbonate like chemicals. So this will be the perfect site where we can store the CO2. So this is the carbon sequestration in geological site. Then we can do the forestation. This is very much like to the artificial trees, and then we can do the conservation, sustainable management of forest, or enhancement of first carbon stock. So this is the red plus. And this the concept of red plus, and this red has been in the conference of parties that happens this COP. I think you have listened about this COP, the conference that happens every year. Okay, so we talked about this mitigation option. Let's talk about this adaptation. So there are three kind of adaptation. I think it will take 5 minutes more, and we will complete it. So there are three kind of adaptation. The first is anticipatory, proactive versus reactive. When when the climate change has been already happened, then we are then we are doing the adaptation. This is the proactive or anticipatory. And if we know that climate change will happen in the near coming years, okay, so and we are doing adaptation for that, so this will be the reactive. Some adaptation has been happened spontaneously, so this will be autonomous or spontaneously. Or some adaptations are planned in nature. Some adaptations are happening by the government itself, and some is happening by the private entities. So the kind of adaptations are private versus public, the spontaneous versus planned, or proactive versus reactive. Okay, and because we have to increase our adaptive capacity for the in the climate change. So what it is, the ability of a system to adjust to climate change. So it is the ability of the system to moderate potential damage, to take advantage of potential, or to cope with the consequences. So this is the definition of adaptive capacity. And what different types of elements we have in the adaptation? First, we will observe, like, whatever the change is happening in the variables. For example, the temperature is increasing, so this we will observe. Then we will assess how much prone we are to the increasing in the temperature. So we will assess it. After assessing, we will plan the strategy. We will do it. We will check it, and after checking, we will adjust whatever we did. So this is PDCA, PDCA cycle. Okay, so this is the elements of adaptation. So there are also three type of adaptation options. The first is we can create resistance to change. For example, if you have listened about the genetically modified crop, what happened in that? We resist we put some genes in such a way that uh, these plants or these crop can resist to the pests. If there is an insect that has been damaging the crop, then we add some genes or some proteins in such a way in the plant that it can resist the pest damage. Okay, so this is the resistance to change. We can promote the resilience to change. For example, we can increase the biodiversity. So after increasing the biodiversity, there will be a lot of options, so where we can adapt ourselves. The third is enable forest to respond to change. Here what we can do is we can manage the forest in such a way that the it respond to the change. Okay, so for example, we are uh, we are assisting natural adaptations and the transitions, and we are here is the assisted migration to the newer areas. So here we are enabling the forest to respond to the change. So these are the adaptation option. This is the last one, maladaptation. What happen whenever we are doing the adaptation? It can be happen that we become more prone to the climate change. For example, if we are buying the ACs, because we are buying the ACs, we need the electricity, and this electricity will come from the burning of fossil fuel. And if we are burning the fossil fuel, we are again increasing the temperature, we are again increasing the greenhouse gases. Okay, so we are just increase the vulnerability to the climate stimuli. So this is the maladaptation. So I think I should stop here because session was only from 6 to 8. I think everything is clear. Are you here, Kuldeep? Oh, yes. Thanks to be there, because today I think some peoples are in market or buying something, or because this is the enjoyment day now. So thank you so much for being here. Yeah, sure, sure, Kuldeep. I hope that you will reach your wherever you're going very fast, and then in the next session we will meet, and you will introduce yourself to me. Okay, thank you so much. We can go and we can exit this Google Meet. Thank you, Kuldeep.